Our solar system feels familiar. We know the planets, their order, and the way they gracefully circle the sun, each following its own unique path. For centuries, we've mapped their journeys, watched their eclipses, and marveled at their beauty. Their majestic dance around the sun is a cosmic ballet, unfolding over millions of years, a spectacle that has inspired wonder and curiosity in every generation. But what if there's a giant, hidden world lurking far beyond Neptune? A planet so remote, so shrouded in darkness that it's managed to keep its secrets from us, until now. A world so distant and faint it's escaped our sight for all of human history. It could be out there, quietly orbiting in the frozen shadows, waiting to be discovered. This isn't science fiction. It's a real mystery astronomers are racing to solve. The hunt for Planet 9 is one of the most exciting quests in modern astronomy, blending cutting-edge science with the thrill of exploration. The story begins with a puzzle. Something strange was happening at the edge of our solar system, a clue that would spark a new era of discovery. Astronomers noticed that a handful of small, icy worlds in the farthest reaches of our solar system weren't moving as expected. Their paths through space seemed to defy explanation. Their orbits were strangely aligned, as if pulled by an unseen force. It was as though something massive yet invisible was shaping their journeys from afar. This echoes how Neptune was discovered, by noticing Uranus's odd orbit and deducing a hidden planet's presence. History seemed to be repeating itself, with new mysteries waiting in the darkness. Now, over a century later, we're asking, what's out there, tugging at these distant worlds? Could it be a ninth planet, or something even stranger? The search for Planet 9 pushes our technology and our understanding of how solar systems form. Every new observation, every simulation, every late night spent scanning the sky brings us closer to solving this cosmic detective story. Each clue adds a piece to the puzzle, revealing more about the hidden architecture of our solar system. Whether we find a planet or something else entirely, the search itself is reshaping our understanding of the cosmos. The journey into the unknown reveals more about our place in the universe. The hunt is on, and with every step, we push the boundaries of what we know. The unknown still beckons from the edge of our solar system, inviting us to keep searching, to keep wondering, and to never stop exploring. To understand this mystery, we travel to the Kuiper Belt, a vast, icy junkyard beyond Neptune. For years we thought it was a chaotic mess, but as telescopes improved, astronomers noticed something odd. A small group of the most distant trans-Neptunian objects, or TNOs, all followed similar tilted paths. Their elongated orbits pointed in the same direction, as if arranged by an invisible hand. The odds of this happening by chance? Astronomically small. The combined gravity of known Kuiper Belt objects couldn't explain this neat formation. Something massive, much bigger than anything we'd found, had to be responsible. Each new discovery fit the pattern, reinforcing the idea that this wasn't a fluke. The orbits of these distant objects were like footprints in the snow, pointing to a hidden giant. The hunt for the source of this gravitational influence was officially on. Astronomers were determined to find what was shaping the destiny of these icy wanderers. Faced with this strange and unexpected alignment of distant objects in the outer solar system, scientists gathered to puzzle over the mystery, and soon proposed a bold, intriguing hypothesis that could rewrite our understanding of the solar system's edge. In 2016, astronomers Konstantin Batygin and Mike Brown suggested that a single massive planet, Planet 9, lurking far beyond Neptune, could be responsible for the unusual clustering. Their detailed computer simulations revealed that a planet 5 to 10 times the mass of Earth, following a vast, elongated orbit, could act as a cosmic shepherd, herding these distant objects into their observed formation. Planet 9, if it exists, would be a true outlier, taking up to 20,000 years to complete a single orbit around the Sun, spending most of its time in the cold, deep darkness at the solar system's edge. Its immense gravity would slowly twist, stretch, and warp the orbits of smaller bodies, acting as a gravitational shepherd and shaping the architecture of the outer solar system over millions of years. This elegant and compelling hypothesis explained not only the clustering, but also the strange tilted orbits of these distant objects, something no other theory had managed to do so neatly. Yet, it's important to remember that Planet 9 remains just a hypothesis. built on indirect evidence, mathematical models, and the gravitational fingerprints it may have left behind, not on direct observation. Badigan and Brown essentially provided a cosmic treasure map, pointing astronomers toward the region of the sky where Planet 9 might be hiding, waiting to be discovered. The next step was clear: move from mathematical prediction to actually spotting the planet with telescopes, a daunting challenge given its distance and faintness. The scientific community now had a clear target, and the race to find Planet 9 began in earnest, with astronomers around the world joining the search. The search was on for a new, mysterious member of our solar family, one that could change our view of the solar system forever. With a theoretical map in hand, astronomers mobilized their tools. The search for Planet 9 is like looking for a black cat in a dark warehouse at midnight. NASA's WISE mission scanned the sky in infrared, hoping to spot the planet's faint heat signature, but found nothing. Cassini's data was checked for gravitational tugs. Again, no luck. These null results didn't disprove Planet 9, but narrowed down where and what to look for. The real breakthrough came from computer simulations. By modeling the solar system with a hypothetical Planet 9, astronomers could predict where it should be now. This turned a blind search into a targeted hunt, focusing telescope time on the most promising regions. Digital detectives, powerful computers, now guide astronomers' eyes to the likeliest hiding spots. The search is more focused than ever, and the chase continues. In science, there's a crucial difference between a hunch and a fact. The Planet 9 hypothesis is compelling, but it's not yet proven. Think of it like a courtroom. Astronomers have strong circumstantial evidence, the clustered orbits, the gravitational clues. But they don't have the smoking gun, a direct image of the planet. Until we see Planet 9 and track its movement, the case remains open. Skepticism is science's strength. Every claim is tested, every alternative considered. Some suggest the clustering is due to many smaller objects or even observational bias. Competing ideas force researchers to gather more evidence and refine their arguments. The goal isn't to prove someone right, but to find the truth. The Planet 9 hypothesis makes a bold, testable prediction. There's a planet out there in a certain region of the sky. Now, we must look. Whether we find it or not, the process itself advances our understanding of the solar system. The search for Planet 9 is about to get a massive boost. High in Chile, the Vera C. Rubin Observatory is preparing to scan the southern sky with the world's largest astronomical camera. Its legacy survey of space and time will create a movie of the universe, capturing anything that moves or changes. This is exactly what's needed to spot a faint, slow-moving object like Planet 9. The observatory will repeatedly scan the regions where simulations predict Planet 9 could be hiding. Sophisticated computer algorithms will sift through the data, flagging any potential moving objects. If Planet 9 is there and within reach, we should find it within the first few years of the survey. Of course, there are no guarantees. The planet could be out of view or even dimmer than expected, but for the first time, we have a tool custom-built for this search. The astronomical community is waiting with bated breath. The next chapter in the hunt is about to begin. What if we find it? What if, after years of searching, we finally spot a new world lurking at the edge of our solar system? The discovery of a ninth planet would instantly change our map of the solar system, redrawing the boundaries of our cosmic neighborhood and expanding our understanding of what's possible. It would be the first super-Earth or mini-Neptune in our own backyard, a type of planet common elsewhere in the galaxy, but never before seen up close by human eyes. Imagine the excitement of seeing a world so different from the rocky planets and gas giants we know. Studying it could reveal how such worlds form, what their atmospheres are like, and whether they could harbor exotic chemistry. We might even learn if these distant planets could support some form of life, or if they hold clues to the origins of our own planet. Its existence would force us to rewrite the story of our solar system's formation, challenging old theories and inspiring new ones about how planets are born and evolve. As Mike Brown said, the most exciting thing would be to find a planet unlike any other in our system, and figure out how it fits in. It would be a puzzle piece we never knew was missing. Finding Planet 9 would open a door to new questions, new missions, and a new era of exploration. Scientists and engineers would dream up new spacecraft to visit, study, and maybe even orbit this mysterious world. Beyond science, it would remind us that great discoveries still await, even in our own cosmic backyard. It would inspire a new generation to look up and wonder what else is out there, waiting to be found. It would connect us to a long tradition of exploration and wonder, linking our curiosity with that of astronomers and adventurers from centuries past. Our family of worlds would grow, and our sense of the universe would deepen, reminding us that the cosmos is always more complex and beautiful than we imagine. The universe, it seems, always has another surprise in store, just waiting for us to discover it. The search for Planet 9 is more than a hunt for a single object. It's the essence of scientific curiosity. Every answer leads to new questions. If we find Planet 9, how did it get there? If not, what else is shaping those orbits? Astronomers are modern explorers, dedicating years to this cosmic puzzle. Even null results, like those from Wise and Cassini, help refine the search. Science is a marathon, not a sprint. Each step, forward or sideways, adds to our knowledge. The process is slow, methodical, and collaborative, with scientists worldwide sharing data and ideas. Whether Planet 9 is found or not, the quest itself is worthwhile. It pushes the boundaries of our knowledge and inspires new generations to look up and wonder. The journey is as important as the destination. The search continues, and so does our sense of wonder. The story of Planet 9 is an invitation to join the adventure of discovery. You don't need a telescope to feel wonder. Just look up. The night sky is a story unfolding above us, full of mysteries and possibilities. Tools like the Vera Rubin Observatory are opening the universe in ways once unimaginable. We're on the verge of answering questions that have inspired humanity for centuries. The search for Planet 9 is a tangible piece of our quest to understand our place in the cosmos. So next time you see the stars, think about what might be hiding in the darkness. This is real science, curiosity, evidence, and the thrill of the hunt. The universe is vast and mysterious, waiting for us to keep looking and keep questioning.